Hi, I'm B. Hofferkamp,
And I'm Nick Simon.
and we built a Hotshot Basketball game for a final project. We built the ramp, we attached a basketball hoop. There's a photo eye that will be counting all the points. It's attached to this counter back here. These lights up here will indicate stop, ready, and go for the first player. Each player has 30 seconds. At the end of the first player's 30 seconds, a fan will start and a buzzer will sound, which will indicate a 10-second cooldown period. During this period, this LED here will blink 9 times. When after the 9th blink, it indicates the second player's turn to go for another 30 seconds. And then a buzzer will sound at the end of the second player's turn, indicating that the game is over. If you get more than 10 points on this counter, a neon light will light up and indicate a set of 10. And they're hooked up to set up to 40 shots. Okay. Go. Game.
All right. Hi, I'm Ben. This is Angela. We will be presenting this project today. What we have made is a threat detection and simulated elimination device sort of thing. So what's going to happen is we're going to have that transformer over there, that current transformer. She's going to move it. It's going to pass in front of the sensor, and that's going to send it in front of the sensor up to the PLC, which is going to start a countdown, which we have hooked up to this this timer here, which will also activate a fire alarm, which will make some light and noise, and then this spinny ball, which is like kind of just the warning light. And then after the countdown finishes, it will activate the conveyor belt, which will then move the transformer to the last sensor down there, which when that sensor is hit, it's going to start the motors, and it's going to activate the elimination device, which is 2 poppers. What we have for the motors is, of course, they're both running through a motor starter, which we'll have to push the button on, and then it's running through a VFD, which is a variable frequency drive, which just we use to control the speed of the motors because we are using small objects there. And then also when the conveyor is not going, that light will be red, and when it is going, that light will be orange. So yeah, we turn everything on. Yeah, I know, I'm going to turn it on. I know, I'm going to turn it on. There we go.
You can go.
Hi, I'm Tom Tomlinson.
Jordan Bredesen.
For our project, we are simulating the Mose Gate that is currently being used in Venice, Italy. The Mose Gate is used to protect the city from floods due to high tides coming in. It can protect from high tides up to 9.8 feet, and it saves the city from major damage.
So here's the fan, which is going to simulate the storms. The red light here indicates whether it's all the way up or all the way down, and then while it's moving or in motion, the buzzer and this yellow light's going to be flashing. So there's a storm. When the storm's over, right back down.
My name's Blake,
I'm Zach.
and our group project was we made a wire tugger, and we used a three-phase motor and a VFD, which is the variable frequency drive. And what that does is it controls the speed of the motor down. That way the rope wouldn't sit and spin on the pulley. We use a neon and an LED to indicate red or green whether the tugger is on or off. We also displayed that on the logo. And he's going to talk a little bit about the switches.
We used 2 switches. This switch is to turn the motor on, and then the second switch is to do forward or reverse for pulling the wire through. And then we did a buzzer. It will go off for 1 second to indicate that the system will start, and then a fan just because. And then we did start and stop to turn the whole thing on.
We already ran the fish tape through the rope up too. And that's our project. Thank you.
I'm Eric Klifke.
Jacob Meidinger. Paul Barkley.
We made an alarm system. When the green light is on, it means it's active. Once you open the door, it'll change to yellow. It'll give you an 8-second delay with an alarm and a flashing light letting you know to put in security code to rearm. After the 8 seconds, it'll go into emergency mode. With the emergency mode, we have flashing lights, a counter that'll count down to 0. Once they hit 0, it'll have a red indicator to know you're calling the cops. And we have a logo to tell you if the door is open or closed. So, go ahead. Put in the passcode, it's rearmed. Go ahead, close the door. And open. He had to act as our horn because it was very, very obnoxious and it hurt some people's eardrums, so we had to disconnect it. Other than that,
If you liked the video, click that like button. If you disliked it, click the dislike button. Leave a comment down below and let us know what we did. And subscribe for more videos in the future.
thank you.
My name is John.
My name is Mike.
I'm Anne Marie, and we have the itty bitty greenhouse.
Yep. So we took, a life-size version of a greenhouse, shrunk it down. We used a 120 volt transformer, 24 volt transformer, a fuse block, thermostat, limit switch, and the control relay. So the program up here. The system is completely automated. So right now what it's doing is, this is the green light, and that is showing you that it's okay to lock in because there's no water running. Gonna wait for it to kick on here. Okay. There we go.
There we go.
So now the water's going, the green light turned off, which is saying that, okay, your water is running. Say you want to go inside, you don't want to get wet. When you open the door, it hits this limit switch, turns everything off, and the green light goes on, saying it's okay to go in. And the normal operating temperature for greenhouse is 70 degrees. And so we put in a fan controlled by this thermostat here to cool it off when it reaches about 85 to 90. It's a little too hot for the greenhouse. So you turn that on. The red light's indicating that it has gotten too hot, so the buzzer sounds to let us know that the fan is going to be running. And you turn it off, it goes off. And so like I said, it's completely automated, so it's going to shut off by itself. And then, there we go. Green light turns on, no water running, it's good to go. That is the automated greenhouse.
Alright, so we use 3 PLC logos to do something that should have been relatively simple to use the S7, but we use the logos because once you get out of school, the world isn't as organized as this. So we made it a little more complicated. We've got AC, we've got everything wired, AC and DC, we've got fans, buzzers, lights, LEDs, and all these different noises. It's called an alarm clock to wake the dead. It's making fun of our morning class because most of them are late for class. We'll press the start button, 5-second delay. Shoots through the 3 stages, green, yellow, red. Gets progressively worse. And it can only be stopped with a stop. So you would have to get up. There is no snooze on this thing.
Okay, so I'm Nate. Wyatt, Austin. This is Tyler, and we made a big buck hunting target shooter game. So our motor here is on a 5-second timer, and it's going to be moving back and forth. Our first start-stop push button is going to give power to our logo. Our second push button is going to give power to our VFD. Our VFD controls our motor, like the motor speed, and also our logo controls the timing on the motor. Our motor is wired for low voltage in a Y. When our motor is in forward bias, we're going to have our red neon LED light on, our fan is going to be on, and our buzzer is going to be going off. And when the motor is in reverse bias, we're going to have our green light on. So just to demonstrate, we can turn it on here. What already is on. Sweet. So if we flip our switches, our gear is going to move back and forth.
Hey.
Oh man. And that's our game.
All right. This is the Swag Soda Squad, and this is Abraham. I'm Daniel. This is Ernesto and Naz, and we made a soda dispenser that dispenses any types of soda that you want, and it is run off of 6-volt DC air pump motors, and it pushes air into the bottle and then comes out a tube into your cup using air pressure. And we wired the stop and start push button of the master control, allowing total overpower to the whole system. And as soon as you press the start button, 3 LED lights, a buzzer will pulse 5 times simultaneously, and And then our logo will read, machine is ready, and then you're ready to dispense your soda.
All right. As said in the description, this is our master control. As soon as you press that start button there, 3 LED lights and a buzzer will pulse simultaneously for 5 seconds, letting you know that the machine is ready. As well as those firing up right away. As soon as you press the start button, a neon light will indicate that the machine is ready. And that'll stay on until de-energized, as well as the fan here. It'll keep you cool while you dispense your soda. And we used a 12-volt power supply here to power our pumps. And that's totally isolated from our 120 power supply that supplies power to our logo here, which sends signals to our inputs and outputs. And that's how we get power. We'll fire it up. Wait for the logo to power up.
Machine on. Okay, machine is ready for use.
So after power up, this neon light is it's letting you know that it's still running, and the fan lets you know that, as well as the lights.
And it's ready to pour up.
Beautiful. And that's our project.